Continuing from the previous videos, I want to show how to do the exact same calculations that were run, but this time I want to demonstrate how to do them using R. I'm going to go ahead and open R. R has a number of built-in functions that allow you to read in CSV files directly. I'm going to open up a note file here that has the functions that I'll be using so I can copy them directly instead of typing them. So the first thing that I want to do is I want to change my working directory to the directory in which I've stored my data, which in this case is just called temp. And now I'm going to use the read.csv function to bring in my data. So read.csv, I give it the file name, which is my_data.csv. That's the CSV file. And then I'll assign that to the value my.data. So if I type my.data, I see that I actually have my values. Now, the next function I'm going to run is an as.data.frame, and I'm specifically saying strings as factors equal false. This is something I do to make sure that the data that I'm reading in is in a format that makes it relatively convenient to move back and forth for a number of common functions. Now, I noticed that the treatment group is values in rows 11 to 20, and my control group, which has a treatment value of 0, is in rows 1 to 10. So what I'm going to do is I'm going to look at my data $post, which focuses just on, so if I look at just my data $post, that gives me the values in the post column. And if I tell it that I want to look at the values from 1 to 10, I indicate that by putting those values in brackets. And I can also look at the values from 11 to 20 as two separate groups. Now the t-test function that I'm about to use here, t.test parenthesis, first array, comma, second array, this runs a test where it assumes that the variance is not equal between the two groups. If I were to include the information, comma, var.equal true, this changes it from a test where it assumes the variances are not the same to a test where it assumes the variances are the same. In this case, I obtain a p-value of 0.1229, which is the same information I obtained when I looked at the post-test scores between the treatment and the control group. Alternatively, I could look at the information for the t-test for looking at the values for the post-test and the pre-test. So this function is now looking at my data $pre, comma, my data $post, and this is saying, now I've indicated that it is a paired test by indicating comma, paired equals true, and this runs a paired t-test, and we see that there essentially is no significant difference between the pre-test and the post-test scores when looking at this data as one large group. Now, as I did in Excel, and as I demonstrated using SPSS, we can calculate the difference score by subtracting my.data post minus my.data pre. And if I were to look at the difference scores, here are the values. Now I'm going to combine this. I'm going to use the cbind function. So my.data has been reassigned to the value cbind my.data, comma, diff. So the only thing I've actually done here is I've actually taken the difference column and added it as a new column into my data set. Now I'm going to do the t-test to compare the different scores for the values in the first 10 rows compared to the values in rows 11 to 20, and I'll assume the variance is equal, and lo and behold, as before, we get a p-value of 0.0009 and change. Right, I'm going to stop here, and I'll do this analysis next using Stata.